Hey guys, so today we're going to do a data science project. We're going to go investigate a car data set and understand the relationship between several features to miles per gallon. So without further ado, let's get started. Alright, so we're going to be doing this project on Kaggle, so please go ahead and click the link in the description. It will link you right to kaggle.com, and then you can go ahead and make an account, so hit register or sign in. And then once you're there, go to the top left and hit create on your Kaggle account and hit new notebook. So once you have your new notebook opened up, you can rename it on the top left. I like to rename mine with keywords about my project. So for this one, I'm going to investigate the miles per gallon of a car. So MPG dataset, and then we're using multi-linear regression. And then in the future, I'll make a part 2 where we use ANOVA. So I'm going to add ANOVA there too. And then we want to make sure that we're going to be using the right language. So I'm going to go hit file and then language to set the language to R. So yeah, great. Once we have the language set, we're going to go import the dataset. I've already put this dataset on Kaggle, so you can actually just type in car mileage on Kaggle. But if you want, you can download the dataset from the description below and then upload that to Kaggle yourself. We're going to import some libraries so that we can make the process more efficient. We're going to import readxl, ggplot, tidyr, and dplyr. It's fine if you don't know these libraries. They're just tools to help your analysis process go more smoothly and faster. It's good for you to research these libraries because they're heavily used in the industry. We want to just run the first block of code to make sure it works and there's no errors. And after that, we can import the dataset. So I'm going to do df equals to read_xl and then the pathway of the dataset. You can type what I'm typing here. You can just copy the pathway. It's on the right hand side. Great, so once we have the dataset imported in, we want to look at the dataset so we understand what's happening. So I'm going to type in head df to see the first 5 rows of the dataset. We know that there's 6 variables here. There's the make model, there's the volume, there's the horsepower, there's the MPG, top speed, and weight. The make model doesn't really help us here. We're going to do a multi-linear regression, which wouldn't work with character data types. So we're going to drop that for now. We can do that by doing df equals to df bracket empty space, comma, -1. So in the brackets, you will see an empty space and a -1. What that means is you don't change anything with the rows. You keep all the rows, but you take away the first column. So the first column here is make model. And we're creating a new data set with the same name of our old data set. Great, so now that we have that, we can we can kind of look at the data set and understand the statistics of the data set. So we're going to use summary df, which essentially tells us the 5-number summary of the data set. So here we see that the volume has a minimum of 50 units, and the units here is 100 cubic meters. We also see some other statistics for the horsepower, miles per gallon, top speed, and weight. I don't like looking at the 5-number summary like this, so I'm gonna visualize it with box plots, and I can do that by doing box plot with the variable name and then title. So I'll write the code here and you guys can copy along. Great, so now that we have all the box plots, we can see that they're all pretty evenly spaced out in terms of minimum value, first quartile, median, third quartile, and maximum. But there definitely are some outliers in this data, as you can see with the dots. So we're going to investigate that later on when we do our ANOVA test. So now that we know this, we want to solve our business test. We want to understand if there's a relationship between these variables and miles per gallon. So the easiest way you can do that is by doing a correlation test. What correlation does is essentially it tells you if there's a relationship, a positive or negative relationship between 2 values. And we're going to use the Pearson's method because we're using quantitative variables here. So as you can see, we have a negative 0.368 correlation between miles per gallon and volume. So this tells us that with every 1 unit increase in volume, the miles per gallon decreases by negative 0.368. So it's also important to know that the p-value means how significant this is. And if the p-value was very big, then we wouldn't consider this significant. We wouldn't conclude that miles per gallon and volume have a relationship. But since the p-value here is very small, it's lesser than 0.05, we can conclude that there is a relationship between these 2 variables. What the confidence interval here tells us is that we are 95% confident the correlation between miles per gallon and volume is between negative 0.542 to negative 0.164. You will need to know this more in statistical hypothesis testing and stuff like that. For this specific project, you don't really need to know it. I'm a visual learner, so I'm going to visualize this. I'm going to try and understand how this looks out on a scatter plot. So this scatter plot does tell us that there's a lot of outliers in the data. You can kind of see a negative pattern in the chunk of data in the middle right there. That kind of tells us that there's a negative correlation between these 2 variables. So I'm going to go ahead and plot a line of best fit or a regression line to visualize that negative correlation better. Great, now that we see that the line of best fit is pointing downwards, we can conclude that there is a negative correlation between these 2. There is a negative relationship between these 2, and the gradient is about negative 0.3. Great, so now we're going to repeat this with all the other features so we have better insights. As you can see here, weight has the highest negative correlation, and it shows in the plot. So this tells us that as the car weight increases, the miles per gallon decreases more significantly. So now that we know the individual relationships between these variables, let's look at the collective relationship. And we can do this by doing a multiple linear regression test. So now once we have that model, we can look at it through the summary function. So this can be pretty overwhelming. The key part here is understanding how these lines work. The equation of a regression line is essentially y equals to mx plus c. So a multiple linear regression line just includes more features. In this case, we have 4 features. So for this specific model, the equation will look something like mpg equals to volume x1 plus horsepower x2 plus weight x3 plus sp x4 plus c. And to get the coefficients, you can look down here on the table and replace all the variables with their respective coefficients. So just the c, the intercept is 192.43, and everything else is listed out here respectively. What this tells us is that provided every other feature stays constant, when the volume increases by 1 unit, the miles per gallon will decrease by a factor of negative 0.015. So this is useful because we can kind of understand the relationship between all the independent variables and the dependent variable and their collective relationship. The next thing I would look at is the p-value. So the stars by the p-value here is which variables are significant. You can see that all variables are significant here except for volume. Like I said before, we consider a feature significant if they have a small p-value, typically a p-value below 0.05. So you can see that weight has the smallest p-value, which means it's the strongest predictor. And then horsepower and speed kind of follow later on. So now we can kind of share our insights. So we know that individually all features are significant in predicting MPG. What's interesting is that when you do it collectively, only weight, top speed, and horsepower are significant when predicting MPG. What this tells us is that there could be a masking effect by the other features, like let's say weight, top speed, and horsepower, that kind of masks the significance of volume in predicting MPG. We call this the multi-collinearity effect. And we can investigate this further on, but for this specific project, we won't. So yeah, that's it guys. I hope you enjoyed this short project. Obviously, you can go more in detail, more complex, and we'll be having a part 2 where we talk about ANOVA and how we're going to use ANOVA to investigate or explore this data set even more. I hope you guys enjoyed, and I'll see you in the next one.